Hello, it's Greg Samways here again to tell you some more about my Critical Thinking in Earth Sciences course. In this short video, I'm going to focus on what you will learn in the course. So the course is divided into 5 chapters, and the first chapter will focus on the first question that I needed to answer, which is, what is critical thinking? If you remember from the previous video, I talked about how I had been a critical thinker for more than 30 years, but I hadn't really thought about critical thinking or what critical thinking was. And of course, before I can teach it, I need to understand it. And likewise, before we can improve our critical thinking, we have to understand what critical thinking is. So in this chapter, we'll learn something about how the mind works, how we process the world around us, how we research, how we learn, and how we store memories. And one of the most important processes is cognition. You'll recognize the word. You use words like recognition without really thinking about it. But what is cognition? I mean, cognition really summarizes our ability to understand the world around us through our senses, through seeing and hearing and tasting and smelling. So how do we process what we observe in the world? That's the process of cognition. Now, cognition is susceptible to biases, cognitive biases. And these are the tricks that our brain plays on us. It's the tricks our brain plays when it's trying to take shortcuts. It's trying to save us time. It's trying to second guess. But these cognitive biases can lead us to making some pretty bad decisions and can ruin our problem solving. So we really need to understand cognition. And we need to be able to speak properly as well. We need to understand cognitive biases. So after we've done that in chapter 1, in chapter 2, we'll look specifically at the cognitive biases that disrupt our thinking in earth sciences. There are almost 200 cognitive biases, I think, described on the Wikipedia page, but we'll be focusing on 20 or more that really happen on a regular basis in earth sciences. And we'll be focusing on those. We'll be looking at examples of those cognitive biases and really understanding and appreciating how often those biases affect our decision making in earth sciences. So having understood the impact on our decision making in earth sciences in chapter 2, chapter 3 will focus very much on how we can avoid those biases. And there are essentially 2 ways we can go about that. We can either improve our personal behaviours, the way that we think as individuals, and we'll look at various ways in which we can do that. Alternatively, we'll look at the ways that organisations can employ strategies to improve the thinking of their staff. And without doubt, you will have already engaged in some of these strategies, but you probably just weren't aware that these are debiasing strategies intended to improve our analytical and problem-solving skills. So we'll learn a lot more about those debiasing strategies and hopefully learn some new strategies that you can develop yourself or develop in your workplace. At the end of that discussion about debiasing strategies, what we'll discover is that in fact we need a huge number of skills to improve our critical thinking and to avoid these cognitive biases. So in chapter 4, we will systematically evaluate those skill sets, and I will get you started on a lot of those skills and give you an introduction to how and where you can learn and develop those skills. So that will be the focus of chapter 4, is understanding the skills that we need to be better critical thinkers. And then, of course, we need to learn how to manage those skills, our skills portfolio. So in chapter 5, I will introduce you to GeoSkills, which is a software platform that my colleagues and I have developed, which you will have access to, which will enable you to self-assess your skills portfolio, and learn more about the gaps in your skills and what you can do to fill those gaps. But let's take a closer look now at those skills. So what I've done with every problem that we encounter in earth sciences, I've taken the skills and I've categorized them. I've done a skills fasces analysis, if you like. So I've divided the skills up into 6 groups, and you can see those groups outlined here. We have research skills, learning skills, knowledge management skills, testing your knowledge. That's an important skill, just to test that you've acquired the knowledge. Then applying your knowledge, and most importantly of all, communicating the results of your problem solving. So those are our main focus groups, our main skills groups. And in terms of research, we need to develop our research skills. Yes, everybody uses Google, but how many of you have actually searched on Google to find out how to search on Google? Not many. I mean, I ask this question in the classroom, and very few have ever searched Google to improve their Google searching skills. And it's not just learning how to use Google. There are many other strategies that we can employ to improve our research superpowers, and that's critical. There is so much that we need to research, and I don't know if you know, but our knowledge and our information is doubling every 18 months. That's astonishing, isn't it? I mean, we're actually, every 18 months, we are learning as much as we've learned in the whole history of mankind. And it's increasing. That's an exponential increase. So we have to become really good at finding information. Next in line is learning. We've all learned. We've all got degrees of some description. We're in jobs that require us to know stuff, so we must have learned. But did anybody actually teach us how to learn? I've been thinking about this for years now, and I think that people who succeeded in the education system were those who somehow acquired learning skills. I don't think many of us were actually, I don't remember being taught how to learn. I remember being taught and somehow learning, but nobody taught me how to learn. So that's something we need to learn, is to learn how to learn. And not only learn how to learn, but learn how to teach. And we'll see later that teaching is one of the best ways to learn. And then, of course, when you've learned how to learn and learned how to teach, then you should teach others how to learn. Just think about that for a while. We also have to decide what we need to learn, because we don't have the mental capacity to learn everything that it's possible to learn. So we have to make decisions about what needs to be learned and what needs to be stored in our knowledge management systems. So everything that we're not going to store up here, we have to store somewhere else. We have to put it in a database or a knowledge base, or I would say a wisdom base as well. And we'll talk about that in the course. So we need to think about all of the possibilities. And it's not just computer systems that we can use to organize and store our information. We'll look at mind maps and cheat sheets and all sorts of other skills and tools that we can use to gather, organize our information, our knowledge, importantly, so that it can be recalled. Having gathered, acquired, stored, managed, organized our knowledge, we also need to test our knowledge. And there are 2 aspects to this. We could be testing our recall from the knowledge that we've chosen to store up here, but also, significantly, we need to test our ability to retrieve the knowledge that we require from our knowledge management systems. So this links back into the research skills. Where have we stored it? How do we get it out? And that will lead us to think more about how we should store it in order to improve how we can recall the information as and when we need it from our databases and our knowledge bases, which of course now we can readily access from our smartphones. And so there's a huge amount of knowledge management and recall and testing of our knowledge and testing of our recall that we need to do to make sure that we actually have the appropriate knowledge in place to enable us to solve the problems that we're trying to solve. And the next in line there is applying that knowledge. We've got those knowledge superpowers. and we know where to find the knowledge, but how do we actually apply the knowledge to solving problems? How do we apply the processes of logical argumentation? How do we analyze? How do we problem solve? How do we hypothesis test? And how do we ensure that our problem solving is not corrupted and disrupted by our cognitive biases? So there's a whole lot we need to learn about applying our knowledge systematically to the problems. Then, of course, finally, it's no good solving the problem, it's no good applying that knowledge if you don't have the ability to then communicate the results of your problem solving. So communication is one of the most important skills that we need, because without that, our problem solving, the results of our hard work, amount to very little. We have to communicate to our colleagues, to industry, to policy makers. There are many different categories that we need to communicate to, and communicate in many different ways. We routinely make presentations, write reports, create publications. We should be increasingly making videos. That's the reporting of the future. We should be making videos routinely, and we should be learning how to tell the stories in those presentations and reports and videos. There are many, many communication skills that we need to be aware of in the first instance, and then develop and learn and improve. These are all skills. And the beauty of skills is if you don't have them, you can acquire them. And if you've got them, you can improve them. And this is what employers want. This is what we need to be able to do. We need to improve our problem-solving skills. We need to broaden our skills portfolio. And we need to discover opportunities to apply those skills to other earth science professions. There's a great need now for people in different sectors to move into different disciplines, to move maybe from petroleum into geothermal energy, into other forms of mineral exploration or hydrogeology. We've got a lot of core skills, which we've seen in the previous slide, which can be applied to all those disciplines. So we should be aware of that and think about how we can achieve that to broaden our opportunities. And of course, by understanding how these critical thinking skills apply to problem solving, then of course I think you enhance your employment potential. In my years as a technical director, I was effectively an employer, and I now understand that what I was looking for in prospective employees was not just technical knowledge, or not even technical knowledge, but I was actually looking for critical thinking skills. I was looking for people who had the capacity to learn, and learn fast. And once they had learned, to apply that knowledge to solving the problem. And once they'd solved the problem, to be able to effectively communicate the results to, in our case, the client, the industrial client. Those are the skills that we really need. Once you've acquired the learning skills, then you can learn any domain-specific technical knowledge. The skill comes in using the knowledge to solve the problem and communicating the results to the client. And that's what I hope we will learn in this course. Not just about critical thinking for critical thinking's sake, but how understanding critical thinking will help you to improve your skills portfolio, and how improving your skills portfolio will make you more employable. So I hope that's whetted your appetite for the course content. What we'll do in the next video is we'll take a closer look at the specifics of the course outline. So once again, thank you very much for listening, and I hope to see you in the next video. Bye for now.